An older subpanel might have outdated wiring practices that were acceptable when installed, but are no longer considered safe or up to code. Firstly, let's address the shared neutral and ground bus. It is possible that the rule requiring separate ground and neutral buses in subpanels was not enforced at the time of the house's construction. However, this is no longer considered good practice and can create potential safety hazards. The neutral and ground wires serve different purposes and should be isolated in a subpanel. The neutral wire carries the return current from electrical devices, while the ground wire provides a path for fault current to flow back to the source, tripping the breaker and preventing electrical shock. Secondly, the floating ground conductor is a critical issue. The conductor coming into the subpanel from the main panel must be properly connected to the ground bus. When it is left unconnected, there is no reliable path for ground faults to return to the service entrance. This creates a serious safety hazard because, in the event of a fault, the electricity could find an unintended path to ground, potentially energizing metal enclosures or appliances and posing a shock risk. Thirdly, multiple hot wires on a single breaker are a code violation. The use of multiple hot wires such as 2 black wires or a red and a black wire on a single breaker can overload the circuit. Each breaker is designed to handle a specific amount of current, and exceeding that limit can cause the breaker to trip or, worse, overheat and start a fire. Fourthly, the overloaded neutral and ground bar issue exists. The neutral and ground bar should only have one wire or one wire not connected to each hole. Overloading the bar can lead to loose connections, arcing, and potential circuit failures. Loose connections increase resistance, which generates heat and can lead to fires. Ensuring proper connections and avoiding overloading the neutral and ground bar are crucial for safety and reliability. Given the identified safety hazards, it is strongly recommended that the subpanel be inspected and upgraded by a licensed electrician. The upgrade should include several key steps. 1. Install a separate ground bus to properly ground all circuits. This involves adding a dedicated ground bus bar to the subpanel and connecting all ground wires to it. 2. Connect the bare ground conductor from the main panel to the ground bus. This provides a reliable path for ground faults to return to the service entrance. 3. Correct the multiple hot wire violations. This may involve adding additional circuits or using tandem breakers to accommodate the existing wiring. 4. Ensure that the neutral and ground bar is not overloaded. This may involve adding additional neutral and ground bars or consolidating circuits. Replacing the older subpanel with a newer model may be necessary to resolve some of these issues. Newer subpanels often have more space, better grounding provisions, and improved safety features. Replacing regular breakers with arc fault circuit interrupter (SI) breakers is recommended for bedroom circuits. SI breakers provide increased protection against electrical fires by detecting arc faults, which are a common cause of fires. Consider installing a separate circuit for the refrigerator to prevent it from being overloaded by other appliances. Refrigerators can draw a significant amount of current, and a dedicated circuit can help ensure that they operate reliably and safely. It is essential to prioritize electrical safety to protect the home and family. Addressing these issues promptly and properly can help prevent electrical hazards and ensure a safe electrical system. When dealing with electrical work, safety should always be the top priority. Electrical systems can be dangerous, and it's essential to take precautions to protect against electrical shock, fire, and other hazards. Firstly, always turn off the power. Before working on any electrical circuit, turn off the power at the main panel. This will help prevent electrical shock. Secondly, use the right tools. Use insulated tools designed for electrical work. This will help protect against electrical shock. Thirdly, wear safety glasses. Wear safety glasses to protect your eyes from sparks and debris. Fourthly, test before touching. Use a voltage tester to make sure the circuit is de-energized before touching any wires. Fifthly, don't work alone. Have someone nearby in case of an emergency. Sixthly, know your limits. If you're not comfortable working on electrical circuits, call a qualified electrician. Seventhly, follow the National Electrical Code, NEC. The NEC provides detailed guidelines for safe electrical installations. Eighthly, inspect your work. After completing the electrical work, inspect it carefully to make sure everything is properly connected and installed. Ninthly, test the circuit. After completing the electrical work, test the circuit to make sure it's working properly. Tenthly, be aware of your surroundings. Be aware of your surroundings when working on electrical circuits. Make sure there are no water leaks or other hazards that could increase the risk of electrical shock. Electrical work can be dangerous, but following these safety precautions can help minimize the risks. Always prioritize safety when working with electricity. The purpose of a subpanel is to distribute electrical power from the main service panel to various branch circuits throughout a specific area of a building. It acts as a smaller distribution point, allowing for more localized control and protection of electrical circuits. The main service panel is the primary point where electrical power enters a building from the utility company. It houses the main breaker, which controls the entire electrical supply to the building, as well as branch circuit breakers that protect individual circuits. A subpanel is connected to the main service panel via a feeder circuit, which is a larger circuit that carries power from the main panel to the subpanel. The feeder circuit is protected by a breaker in the main panel, sized appropriately for the subpanel's capacity. Subpanels are commonly used in several situations. Firstly, in large homes or buildings, a subpanel may be installed to serve a specific area, such as a basement, garage, or addition. This allows for better control and distribution of power to that area. Secondly, in workshops or garages, a subpanel can provide dedicated circuits for power tools and equipment, preventing overloads on the main panel. Thirdly, in outbuildings, such as sheds or barns, a subpanel can provide electrical power without running numerous circuits from the main panel. A subpanel typically contains a neutral bus bar, a ground bus bar, and multiple circuit breakers. The neutral bus bar is where all the neutral wires from the branch circuits are connected. The ground bus bar is where all the ground wires from the branch circuits are connected. The circuit breakers protect individual circuits from overloads and short circuits. The size of a subpanel is determined by the amount of power it needs to supply. Subpanels are typically rated in amps, such as 60 amps, 100 amps, or 200 amps. The size of the subpanel should be sufficient to handle the anticipated load of all the circuits it will serve. When installing a subpanel, it's essential to follow all applicable electrical codes and regulations. This includes properly sizing the feeder circuit, grounding the subpanel, and using the correct wiring methods. It's also important to label all the circuits in the subpanel for easy identification. A properly installed and maintained subpanel can provide a safe and reliable source of electrical power for a specific area of a building. It's a valuable component of any electrical system, allowing for better control and protection of electrical circuits. The neutral bus bar is a crucial component in an electrical panel, serving as the termination point for all neutral wires in the electrical system. The neutral wire carries the return current from electrical devices back to the source, completing the circuit. The neutral bus bar is typically a metal bar with multiple screw terminals or connection points, allowing for the connection of numerous neutral wires. It is electrically isolated from the panel enclosure and connected to the neutral conductor from the main service panel. The ground bus bar, on the other hand, provides a connection point for all grounding conductors in the electrical system. Grounding conductors are designed to provide a safe path for fault current to flow back to the source, tripping a breaker or fuse and preventing electrical shock. The ground bus bar is typically bonded to the metal enclosure of the electrical panel and connected to the grounding electrode system, which consists of grounding rods, metal water pipes, or other approved grounding methods. In a properly wired electrical system, the neutral and ground bus bars are kept separate in subpanels. This separation ensures that neutral current does not flow through the grounding system, which could create a shock hazard. The only point where the neutral and ground are connected is at the main service panel. The importance of separating neutral and ground wires in subpanels cannot be overstated. Firstly, it prevents neutral current from flowing through the grounding system. Secondly, it reduces the risk of electrical shock. Thirdly, it ensures proper operation of ground fault circuit interrupters, GFCIs. GFCIs are designed to detect even small amounts of current leakage to ground and trip the circuit, preventing an electrical shock. If the neutral and ground are connected in a subpanel, the GFCI may not function properly. When installing or maintaining an electrical panel, it's essential to follow these guidelines. Firstly, identify the neutral and ground bus bars. Secondly, ensure that the neutral and ground bus bars are separate in subpanels. Thirdly, connect all neutral wires to the neutral bus bar. Fourthly, connect all grounding conductors to the ground bus bar. Fifthly, verify the connections. Maintaining proper separation between neutral and ground wires is crucial for electrical safety. Understanding the functions of neutral and ground bus bars and following proper wiring practices can help ensure a safe and reliable electrical system. When assessing the condition of an older electrical panel, several factors should be considered to determine its safety and suitability for continued use. Firstly, check for signs of physical damage, such as rust, corrosion, or cracks. These can compromise the integrity of the panel and its components. Secondly, inspect the wiring for signs of deterioration, such as frayed insulation, loose connections, or overheating. Deteriorated wiring can create fire hazards and electrical shock risks. Thirdly, look for evidence of past electrical problems, such as burned or discolored breakers, outlets, or switches. These may indicate underlying issues that need to be addressed. Fourthly, evaluate the panel's capacity to meet current electrical demands. An overloaded panel can lead to overheating, breaker tripping, and potential fire hazards. Fifthly, assess the panel's compliance with current electrical codes and standards. Older panels may not meet current safety requirements. If any of these issues are identified, it's important to take corrective action promptly. This may involve replacing the panel, repairing damaged wiring, or upgrading the electrical service to meet current demands. A qualified electrician can perform a thorough inspection of the electrical panel and provide recommendations for necessary repairs or upgrades. Several factors may indicate that an electrical panel needs to be replaced. Firstly, the panel is outdated or obsolete. Older panels may lack modern safety features and may not be able to handle the electrical demands of today's homes. Secondly, the panel is damaged or deteriorated. Physical damage or deterioration can compromise the panel's safety and reliability. Thirdly, the panel is frequently tripping breakers. Frequent breaker tripping may indicate an overloaded panel or underlying wiring problems. Fourthly, the panel does not meet current electrical codes and standards. If the panel does not comply with current safety requirements, it should be replaced. Fifthly, the panel is undersized for the current electrical load. An undersized panel can lead to overheating, breaker tripping, and potential fire hazards. Replacing an electrical panel is a significant undertaking that should be performed by a qualified electrician. It involves disconnecting the power to the panel, removing the old panel, installing the new panel, and reconnecting the wiring. The electrician will also ensure that the new panel meets all applicable electrical codes and standards. A well-maintained electrical panel is essential for the safe and reliable operation of the electrical system. Regular inspections and prompt repairs can help prevent electrical hazards and ensure that the panel meets current safety standards. Understanding the condition of the older electrical panel, the potential hazards, and the factors that indicate the need for a replacement can help make informed decisions about electrical safety. Always prioritize electrical safety and seek the advice of a qualified electrician when dealing with electrical issues. In addition to the issues already discussed, there are several other electrical hazards that homeowners should be aware of. Firstly, overloaded circuits occur when too many electrical devices are plugged into a single circuit. This can cause the circuit to overheat and potentially start a fire. Secondly, loose wiring can create fire hazards and electrical shock risks. Loose connections can cause arcing, which generates heat and can ignite nearby materials. Thirdly, damaged outlets and switches can pose electrical shock risks. Cracked or broken outlets and switches should be replaced promptly. Fourthly, improper use of extension cords can be dangerous. Extension cords should only be used temporarily and should not be overloaded. Fifthly, water and electricity do not mix. Water can conduct electricity and create a serious electrical shock hazard. Keep electrical devices away from water and avoid using electrical appliances in wet areas. Regular inspections of the electrical system can help identify potential hazards before they cause problems. Homeowners should inspect their electrical outlets, switches, and cords regularly for signs of damage. They should also test the ground fault circuit interrupters, GFCIs, periodically to ensure that they are functioning properly. If any electrical hazards are identified, they should be addressed promptly by a qualified electrician. Electrical safety is a shared responsibility. Homeowners should take steps to protect themselves and their families from electrical hazards. By being aware of the risks and taking preventive measures, homeowners can help ensure a safe electrical system. In older homes, it's not uncommon to find wiring that is outdated or no longer meets current safety standards. One common issue is the lack of grounding in older electrical systems. Grounding provides a path for fault current to flow back to the source, tripping a breaker or fuse and preventing electrical shock. Another issue is the use of aluminum wiring, which was common in some homes built in the 1960s and 1970s. Aluminum wiring can corrode and loosen over time, creating fire hazards. Another common issue is the presence of knob and tube wiring, which was used in homes built before the 1940s. Knob and tube wiring is not grounded and can be a fire hazard if not properly maintained. If an older home has any of these wiring issues, it's important to have the wiring inspected by a qualified electrician. The electrician can assess the condition of the wiring and recommend necessary repairs or upgrades. Upgrading the wiring in an older home can be a significant undertaking, but it's an important investment in safety. Replacing the outdated wiring with modern wiring can help prevent electrical hazards and ensure that the electrical system meets current safety standards. The National Electrical Code, NEC, is a comprehensive set of standards for electrical installations. The NEC is updated every 3 years to reflect changes in technology and best practices. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. Compliance with the NEC is essential for ensuring the safety of electrical installations. Many local jurisdictions adopt the NEC as their electrical code. Homeowners should be familiar with the electrical codes in their area and ensure that all electrical work is performed in accordance with these codes. When hiring an electrician, it's important to choose a qualified and licensed professional. A qualified electrician will have the knowledge and experience to perform electrical work safely and in accordance with the NEC. A licensed electrician will be properly insured and bonded, providing additional protection for the homeowner. Before hiring an electrician, ask for references and check the electrician's license status with the local licensing board. Also, get a written estimate for the work before it begins. Electrical work can be complex and dangerous, so it's important to choose an electrician carefully. A well-maintained electrical system is essential for the safe and reliable operation of the home. Regular inspections and prompt repairs can help prevent electrical hazards and ensure that the electrical system meets current safety standards. By being aware of potential electrical hazards and taking preventive measures, homeowners can help protect themselves and their families from electrical shock and fire. Always prioritize electrical safety and seek the advice of a qualified electrician when dealing with electrical issues. Consider the wire gauge for the wiring in the subpanel. The wire gauge refers to the physical size of the wire and determines its current carrying capacity. Thicker wires can handle more current than thinner wires. The appropriate wire gauge for a circuit depends on the circuit's amperage rating. The NEC provides tables that specify the minimum wire gauge for various amperage ratings. It's essential to use the correct wire gauge to prevent overheating and fire hazards. Undersized wires can overheat and melt the insulation, creating a risk of fire. When selecting wire for an electrical circuit, consider the following factors. Firstly, the amperage rating of the circuit. Secondly, the length of the wire run. Longer wire runs require thicker wires to compensate for voltage drop. Thirdly, the type of insulation. Different types of insulation have different temperature ratings. Fourthly, the environment in which the wire will be installed. Wires installed in wet or corrosive environments require special insulation. It's also important to use the correct type of wire for the application. For example, non-metallic NM cable is commonly used for residential wiring, while armored cable AC is used for commercial and industrial wiring. When working with electrical wiring, always follow the NEC guidelines and use the correct tools and materials. Improper wiring can create fire hazards and electrical shock risks. When making wire connections, use approved connectors and ensure that the connections are tight. Loose connections can cause arcing, which generates heat and can ignite nearby materials. Always inspect the wiring after completing the work to ensure that everything is properly connected and installed. If unsure about any aspect of the wiring, consult a qualified electrician. Selecting the correct wire gauge and type is crucial for ensuring the safety and reliability of the electrical system. Always follow the NEC guidelines and use the correct tools and materials.